This is a demo of the PERICLES extraction tool, or PET for short, developed by Fabio Carobolo from the University of Liverpool and Annegret Eggers from the University of Göttingen. The tool was released on the 1st of November 2014 on GitHub under an Apache 2 license. The tool captures significant information from the digital environment of a digital object. It is intended to be used for a shear curation scenario, meaning that it runs in the background and does not impair the users while they are working as usual. In a nutshell, the PET monitors the user's computer and in the background captures and stores significant environment information, such as system properties, resource usage, and implicit dependency on documentation, external data, processes, and services. It encompasses system-wide information, file-specific information, and event information. All the user needs to do is download and install the tool and configure a profile specifying the user information they want to extract. They can analyze and consult stored information to understand dependencies and change. Significant environment information can be roughly defined as information you might need for future use according to your purposes and intentions. So what does the PET tool offer that's new? It includes environment information and provides additional metadata of which the user is often not aware, or which existing metadata extraction tools are not capturing. It also monitors the digital object and its environment continuously and captures all new information that arises from any manipulation of the digital object. It can thus help understand the impact change might have. The captured information could, for example, help design virtual machines to provide long-term access to digital objects. Information extraction starts at the creation of data. Existing information extraction tools can be integrated into the PET to further extend its capabilities. Typical examples of environment information would be technical system information, such as operating system and system architecture, digital object metadata, including descriptive, structural, and technical, user, policy, and process information, such as user background knowledge and user interaction with documents, implicit knowledge about what data is useful to the use of the digital object, for example, user knowledge about what is relevant in the collection, and all other information necessary to make use of the object, for example, auxiliary data such as calibration data, support sensor data, or external documentation. So let's get started with the demo. We will now guide you through the use of the PET tool. Go to the PERICLES site on GitHub and click on PET. The only requirement for use of PET is Java Runtime 7 or higher. Just download the PET package and extract the zip archive. No further installation is needed. Execute the jar file in the extracted directory. See the quick guide on GitHub for information on how to execute the file with different operating systems. PET will open its graphical user interface, or GUI, which is organized into the following tabs. The Monitored Files tab lists the files that should be investigated. The Modules tab is for configuring which information should be extracted. The Environment Information tab shows extracted environment information. The Events tab lists all environment events that were detected by the tool. Extracted environment information that is file dependent can also be browsed in the Monitored Files tab by selecting the belonging file. Profiles allow the organization of extraction modules and files for different scenarios. At the bottom of the interface are the buttons to control the extraction modes. The tool is not domain-specific, but modular. Click on Modules. Initially, this is empty. You can customize the tool by adding different modules. You can see there are quite a few modules available, including monitoring modules that run in the background. The different icons indicate whether the information is system-wide or file-specific. The red modules need configuration to suit your needs. You should create a profile to best adapt to your use case, as using all modules would normally not make sense. It would use a lot of CPU and generate a massive amount of information, of which much might be useless or would not want to be extracted, for example, for privacy reasons. You can create a new profile from scratch or from existing templates. For example, the system specification snapshot profile. You can see that it includes a list of modules and that now we can add and remove modules from this list. Based on these profile configurations, you can customize the PET for a specific domain or purpose. For an optimal profile, you would need to do some testing with the tool and check the results of the different modules to adjust their configuration. The capture of environment information can target the host system as a whole. To initiate this, you can make a snapshot of the system. You can see the information captured here, for example, includes CPU and graphics card specification and properties. You can also select the file or files in question and see file-specific environment information. You can see this information in the list of extraction modules displayed automatically in the right-hand window. Some of this information would be lost or changed if, for example, we move the data to another location. Now we will look at how the tool monitors in a live environment. In the default profile, we add the Apache Tika extractor module to track file content change. We open a test document and add another line. Then we save, and when moving back to the PET screen, you will see that you have a new extraction automatically triggered. You can even visualize the change. Here is the extracted information which describes this new line. You can go back to a certain point in time to see the differences between then and a later point. For example, when you find that a file suddenly does not render faithfully anymore or is inaccessible, you can compare the differences in the extracted information before and after the problem occurred. To narrow down a search, we can choose to only show specific extraction modules. You can export the table into an Excel file that can be accessed from the PET data folder. You can also use the PET to monitor human activities that might not have been documented by that person. In our daily operations, we are not always aware of dependencies important to the long-term reuse of the digital object we have created or manipulated, and therefore might easily fail to document these. To trace back what a user did might assist problem-solving processes and help understand any activity involving that person's tacit knowledge which otherwise might be lost. In order to understand the processes involved in creating a specific digital object, for example, to retrace which programs or files were used, you can view the events surrounding a chosen file as a timeline. Here you can visualize actions including all documents that were opened and for how long, and infer the importance they had for creating the file in question. You can infer dependencies between the creation of the examined file with other documents or resources. You can also export the profiles and extracted data. This is where the data and profiles will be stored on your computer. When we developed the tool, we only had a limited scope for testing and adapting it to a wider range of application scenarios. It has not been developed as a market-ready tool, but as a proof of concept for its usefulness in the model-driven approach we pursue in PERICLES. Hence, we released it as an open source tool for everyone to develop further at their own leisure. In the following, we would like to present you with some of the application examples we developed with our use case partners, Tate and BUSOC. The first application example is linked to the art domain. Let's say a software-based artwork is to be migrated to a new computer system for the purpose of an exhibition. The software component of the software-based artwork has a strong dependency on the computer system environment. We need environment information to analyze problems the migration might cause. For example, external running processes that can affect the availability of resources or external network dependencies. For example, software execution speed changes based on available system resources. Information about display settings such as color profile and resolution, used fonts, and the graphics card and its driver are all significant dependencies that can affect the artwork's appearance and are necessary to know in order to maintain the original execution speed and quality of the artwork. The second example shows the usefulness of the PET for enabling emulation as a long-term digital preservation solution. The original appearance and behavior of the software cannot be accurately reconstructed based only on the object-related metadata. The determination, extraction, and preservation of significant environment information is essential to solving the problem of enabling a faithful emulation of the original system. For example, information about the computer system specifications, required resources, installed software, and software dependencies. The third example exemplifies how PET could be applied to the validation of scientific measurements made by scientific instruments. In this scenario, frequent comparisons are made with the data collected independently by other scientific teams. Often the techniques and instruments are different between teams, and this metadata provides a way to ensure the results are not subject to unrecognized effects caused by the different experimental methods used. The purpose of the significant environment information in this case is the validation of the scientific data by the science community. As such, it can assist scientists in assessing the quality and reliability of the data produced. Thank you for your attention.